So Algebra 2, we're in 6.7. I'm going to film a double video on this video that'll cover today's and tomorrow's. 6.7, we're building on our skills from 6.6. 6.6, we were solving equations that had fractions. What we did was we picked an LCM, and then we multiplied everything by that LCM to cancel the bottoms, and to change the tops, and that stepped us out of Algebra 2 into Algebra 1, and we'd have an easier equation to solve. Okay, what 6.6 is about is going to be solving word problems. So they'll give us a paragraph or a situation, and we're going to have to create a problem that's going to have a ton of fractions in it, and then we're going to use yesterday's skills to solve that. So we usually spend 2 days here. Today, if you're watching this in a future year than 2022, on February 3rd of 2022 in history, it drizzled, and it was 40 degrees, and every school closed, and no one understood why. It was bizarre. If you're in live this year of 2022 watching this, I don't know, you're enjoying your snow day, which is actually a drizzle day, you know, having drizzle ball fights and doing drizzle angels and doing whatever you do when it drizzles, I guess, instead of when it snows. But 6.7 is split in two halves. The Thursday half, 6.7 part 1 would be the first half of the board. Then I'll just keep going and do the tomorrow, because it sounds like tonight there's an actual like storm with ice and snow, and if people closed over drizzle, I can't imagine they're going to stay open over like ice and snow. Today it's 40, tomorrow it's like 20, so I can't imagine if the new standard is drizzles at 40, we close. It's hard to imagine that tomorrow will be in person based on districts and transportation and choices people make. So this will cover today, tomorrow. If you want to watch it in one swoop, go for it. You want to split it up, you split it up, that's your call. But 6.7 part 1 has a foundational new idea to some of the problems. Not a complicated idea, but here's a foundational idea to do a few of these. If you can do a job in T hours, if you were here in person, I'd ask how much of that you could do in an hour, and then we'd probably look at each other in silence for a little while, and maybe somebody would come up with that. If you can come up with that at home because you're thinking is good rather than just watching me, great. If not, eventually I'll drop a hint sometimes. I'd say something like, let me change this T to a number, because sometimes people think better in terms of concrete numbers than abstract variables. So let's say if I can do a job in 2 hours, how much of it can I do in 1 hour? Somebody would successfully and hopefully quickly think, oh, 2 hours, you can do half of that in an hour. Well, what if it were a 10-hour job? If it takes 10 hours to do a job, how much of it could we do in 1 hour only? Hopefully some people could think up 1/10, 10-hour job, 1/10 per hour. And then we're on the right track. If it's a T-hour job, we could do 1/T of that in 1 hour. So 2's become halves, and 3's become thirds, and 4's become fourths, and all of that. And that's going to help us in these problems, because these problems are designed to have fractions. That's why they're in this chapter. So this whole chapter is about fraction algebra stuff, fractional expressions, rational expressions, whatever word you like for those. So if you don't have fractions, you're on the wrong track in this group of homework. 271, example 1 is my first thing that I'm going to work through. It says Tom can mow a lawn in 4 hours. Penny can mow the lawn in 5 hours. If they work together with 2 lawnmowers, they want to figure out how long it takes to mow the lawn. So this is what you're going to do, is do this deal where you turn the hours into fractions by going 1 over things. So when they're talking about Tom being a 4-hour guy, we're going to go 1/4. He does 1/4 of the job each hour. Penny was a 5-hour job person, so she does 1/5 per hour. Then they have us working together, so we're going to add them, and the end result will do an equals. We don't know what it's going to take them to do this job together, but this is not going to be an X, it's going to be a 1/X. Together, it's taking them a mystery amount of hours, but we're continuing to do fractions of hours to be consistent. If he was 1/4 because of his 4, she's 1/5 because of her 5, this is 1/X, because we just don't know what the X is supposed to be. Okay, so we're going to create a problem like that. Then we've got to solve it. So here's yesterday's skills. Yesterday's skills, whether you were or weren't here yesterday, we look at all the bottoms, 4, 5x, and we have to pick an LCM. The LCM we pick, 4 and 5, go into 20. but there also needs to be an x, because for LCM picking, we pick things the most that they occur. The job of this LCM is to multiply each term, canceling the bottom, and if there's leftovers, we'll multiply the top. So when 20 cancels 4, that leaves us 5. We're also left with x. That multiplies the 1, and now that's a 5x. When 20 cancels 5, it leaves you 4, but also x. That multiplies the top, that's 4x. And when this cancels the x, it leaves you 20 times the top, and we've got 20. And now we're out of Algebra 2. We're into Algebra 1, or even maybe 7th grade, or somewhere deep in our history. We just have to combine these, so that's 9x equals 20. To get the x alone, do the opposite. That's multiplying 9, all divide by 9. 20 over 9 is technically correct. I'd prefer 2 2/9. Because if somebody said to you, how long is it going to take to mow the grass today, do you think? There's no way you'd say 20/9 of an hour. You might say 2 hours and some change. That's more what you'd say. So we'd rather get this to a more presentable form if we can. Ideally, you'd go like hours and minutes or something, but 2/9 of an hour, changing that to minutes, that'd be a real pain. That's not going to work out evenly anyway. That's going to be like 13 and some change or something like that a minute. It'd just be weird. Then I'm going straight to homework problems. I'm going to start 3 of the homework problems for you, and then you can finish these and do the other ones as well. The homework for this day is on 273. We're going to work from 1 through 6, and I'm going to start you on 1 and 5. Then we'll skip down to the middle and do 15 to 20, and I'm going to start you on 19. And then you would do 23, 24. That would be today's deal on this. So starting you on number 1, they say the reciprocal of 5 plus the reciprocal of 7 is the reciprocal of what number? I'd encourage you to pause the video, see if you can write that yourself. If you can't, come back and I'll show you. But for this, it's just one of those kind of stories. You'll just take it a number at a time. Reciprocal means flip. So as you read, it's saying to you, flip a 5. Flipping 5 gets you 1/5. Because 5 itself is invisibly on top of 1, reciprocal means to flip. So reciprocal of 5, go 1/5. Plus, obviously, has to be plus. Reciprocal of 7 would be 1/7 in the same sort of way that we got the 1/5. Is always equals. Reciprocal of a mystery number, we're going to go 1 on top of a variable, and that's your head start on 1. I'm not going to solve that. You can solve that. Solving that is the exact same way we just solved this. So the way we solved this with a 20x, doing a lot of canceling and changing, this is going to have a 35x, do a lot of canceling and changing. But I think you should be able to manage that by patterning after what we did in 1. One thing that's a little easier on this one, an answer like 29 would be fine, because they're not talking about hours or something specific in the real world. They're just talking about numbers, just whatever random number it is. So whether it's mixed or whole or improper, no one cares. 2, 3, 4 are not going to be very different than 1. So if you model 1, 2, 3, 4 after what we had over there, the only real difference I can see, it looks like on one of these they're saying like 6 times a reciprocal. So if over here I was doing 6 times a reciprocal, this would change to 6. Or if this were 3 times the reciprocal, that would become a 3. This story didn't do that, so I'm going to erase that back away. But if they introduce other numbers, that just changes the 1s to those other numbers on the top. Other than that, that looks about the same to me. Another small difference, they're not all reciprocals. This, they said reciprocal 3 times, so they're all 1/overs. It looks like in 3 and 4, not every number has a reciprocal, so if they just flat out say 8, you can just leave it as an 8. Reciprocal of 8 would be 1/8, but if they just say 8, just leave it 8. 5, they say, we have a fraction, and again, maybe pause the video, see if you can write this yourself. And if you can't, come back and I'll do it when you unpause, obviously. But give it a read, see if you can. For 5, it says there's a fractional numeral The numerator, which means the top, is 3 more than the denominator. So our start would be we'd have an x on the bottom. We don't know the denominator. We don't know the top either, so that also has to do with x, but it's 3 or more. So that's our start. We have a fraction, the top's 3 more than the bottom. Then we're supposed to add 2 to both the top and the bottom. So add 2 there, add 2 there. Then they drop the magic word is, which is equals, and then they want to have a 3/2 there. So that problem has been written. If this were a quiz, it's usually 1 point for writing it, 1 point for solving it, so you'd be in for that first point, we wrote it. Cleaning this up a little bit, the +3 +2 is just weird to look at. So we would change this to a 5, and now we'd have a flashback to yesterday. Yesterday, some of the questions we could shortcut. One of the shortcuts available to us was when there were 2 fractions that were equal, the quickest way to do this is to cross multiply. Cross multiply means this top, which has invisible parentheses, would multiply by 2. So you'd get a distributing result, and equals. And then this bottom is also invisibly in parentheses, and that wants to multiply the 3. And I'll leave that to you to solve. 2 distributes this to be one side of an equals. 3 distributes that to be the other side of the equals. You'd go, 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 go. In the end, let's say you got x equals 10. It's not x equals 10, that's not the right answer, but if you did get x equals 10, let's look at the end of 5. When we get done with 5, they're not asking you to find x. They're asking you to find the original fraction. So a minute ago, before I did those changes, this is where we came in. The original fraction was x plus 3 over x. Once we get x, and they want to know what the original fraction was, they're expecting you to plug that number back in there. So our original fraction was x plus 3 over x. If we put the 10 back in there, we'd come up with 13 on top of 10. And again, 10 is not the answer, it's something else. But whatever the answer is that you get from solving, make a fraction by doing it on the bottom and it plus 3 on the top. 6 is just like 5, and then we skip through the middle for a while in the homework, and we're resuming down, looks like on 15. So 15, 16, 17, 18, 19, 20, we're back to the questions like the working for the hours and the fractions of the hours things on those. 19, they say, instead of having Tom and whoever, forget their name, we had Tom and Penny a minute ago. Instead of Tom and Penny, this time there's not people working together, but they're filling a swimming pool with a pipe and a hose. So the pipe and the hose work together. So they say the pipe alone would take 12 hours. So back here, the Tom's 4 made a 4th, Penny's 5 made a 5th. On this, we have a pipe that's 12, so we're going to go 1/12. The pipe is working with a hose. So the hose is going to be 1 over some sort of number that they have to give us in the book. The grand total is going to be 1 over a mystery number that we don't know. Okay, so one thing plus the other thing equals a total. The numbers they give us are going to end up on the bottoms of some 1s. 8 4/7 is sort of an awkward number, and that's why I picked 19 to help you with instead of just leaving you hanging with 19, because that's sort of a rougher one to deal with than just 4s and 5s. So here's my suggestion for this. If they give you a mixed number, change it. 8 4/7, if you go 7th grade flashback, 8 4/7, you do the bottom times the whole plus the top. An alternative to 8 4/7 is 67. Then an alternative to thinking of this as a fraction, this symbol means to divide. We have 1 dividing another fraction. And when you divide by a fraction, that means you should flip it. Okay, so if 1 divides 67, our grand total on this is going to become 7/60. And now we're good. Now we're back to doing what we were doing the other day. We pick an LCM, 12 and 60 both go into 60. There's also an X, and we go ahead and go at it now, and I'll leave that to you to solve. 20 does a little bit of a different thing. 20, when you set up 20, you're going to have a 1 over 9.9. So I'd suggest you go through, you know, the quickest thing to do on this, if you have a fraction with decimals in it, this also has a decimal in it. Just move them both over the same amount. And on 20, that's going to become a 10 over a 99 once you move that. So the decimal they give you, that's that 9.9, 1 over 9.9, just move them. And that covers us 6-7 part 1. So if it's Thursday and you've had your fill, do that homework and tune back into this video at the halfway point tomorrow to get 6-7-2. If you're feeling like you'd rather just get 2 days out of the way, then just keep on watching and we'll dig into 6-7 part 2 and just keep going. 6-7 part 2, we'll do some more practice problems. I'll start you on some more homework problems. This part of the homework will be same page. We're still on 273. We've spilled into 274. We're working today from 7 to 14 as well as 21, 22. So 7 to 14, 21, 22. So these are going to be based on rate, time, distance questions. So tables are back from your Algebra 1 days. Key idea is that rates times time make distances. That's just a thing. We've known that for a long time. Some of these questions, it's going to be helpful to use that formula in that format, maybe. But more often, we're going to want to reshuffle this so that rate is alone or time is alone. So if I use our algebra skills to do some opposites, the opposite of multiplying would make us divide. If I wanted rate alone, rate would equal the distance divided by the time. And if I wanted the time to get alone, I'd have to divide by rate. The time would be the distance divided by the rate. These are more likely the formats we're going to use to do this homework because the goal of this chapter is to help us do things with fractions. And so if we're working through this, that's unlikely today because there's no fractions in that. Very likely we're going to want to work through the fraction formats of these. So on 273, the first thing that we'll work through the whole way together is there's a problem in the middle in red. It says try this. It's about 2/3 of the way down the page on 273. It says there's a boat that's traveling downstream, and then later it's going to do a contrast to go upstream, and we're going to try to fill some numbers in this table. It's going to be more beneficial to you to pause the video and see if you can fill some numbers in the table and check back in on me than to just spectate this, but it's your video life, you can do what you want. So what we're looking at here is it says they're going to travel 246 downstream. That's a distance downstream. Distance always has to do with how far. That's going to be like miles or kilometers or feet or something like that. Time has to do with how long, and that's obviously hours, minutes, seconds, that kind of thing. Rate deals with how fast. That's going to usually have the word per in it, miles per hour, meters per second, that kind of a thing. But the first number we encounter is 246. That's a distance. The next thing I encounter that matters, it says same time. It doesn't tell us what the times are, but it tells us the times are the same. So those are both going to be a variable and be the same variable. Then 180 miles upstream is the 180 for distance. That's the other, how far. And then the how fast are both sort of a mystery. The how fast, we don't know the speed of the boat, but we know the speed of the current, the river, the stream, is 5.5. So when you go downstream, the river's going to help you by adding. If your boat goes a certain speed, and then the river is going and helping you go downstream, you'd add those together. You're going to be faster than you ordinarily would because you're helping each other. When you go upstream, it's a battle, and we're going to subtract when we go upstream. And you're going to have to be careful of the order of the subtracts. Okay, the add, you could add in any order. The subtracts, you have to be careful. In these stories, what you're always going to do first is the vehicle's capability, the boat, the plane, the train, the person, the bike, the whatever. the thing that the human is doing, and then add or subtract some sort of thing like rivers, winds, whatever it is that's working with and against you, that goes second. So the thing that's human driven is going to be first, and then subtract or add, and the add doesn't matter if you get the order out, but the subtract sure does. We'd subtract what the wind or river did. So on this, we don't know what the vehicle is doing, so our variable would go first. We do know the 5.5 is what the river does, the stream does, that's going to hurt or help us. So those are our rates. If they had said something like the boat goes 50 and the river we don't know, you'd have had to do the 50s first because we want the vehicle first. If we know it or if we don't, whether it's a variable or a number, the vehicle goes first and then the other thing goes second. So there's our table. The tables will build about the same way. Then you want to look for, there's always going to be some column with matches. Okay, here the t's are a match. So I'm going to go to the equation based on times. So times are all same. Go find the time equation. We want to put each distance on top of its rate. So distance on top of rate for the downstream, 246 is on top of the r plus 5.5. The 180 is on top of its rate. This distance on top of this rate is a rate minus a 5.5. And those are equal. And then we go at it with our skills from 6.6. When there's two fractions that are equal, our best bet is to try to cross multiply. So we want to multiply these. So 246 will distribute this. 246 distributing that would be a 246r minus 1230. I think that's 1353 if there were people in the room. I'd have somebody check that for me. No one's in the room, so let me just double check that, but I feel pretty good about that. Yeah, 1353 is a win. Then we're going to multiply these. So 180 is going to distribute that, which is going to be 180r minus that plus definite 990 without question. Not going to check that, I'm very sure. If we're solving this, we're going to get these r's to a side. If 180 gets subtracted from 246, I'll pop up here where I have some space. There'll be 66 r's. If I add the 1353 over to the other number, that's going to be 2343. And then we have to divide to figure out the rate. I'm not feeling that one. That's not going to go evenly. That's going to be like something and a half. Under 40, more than 30. 35 and a half, maybe? I don't know, let's see. Yeah, 35 and a half. So the rate of the boat is 35 and a half, and we're out. Today I think they're all of this format, but I'm going to get you started on 3, so let's take a peek. So homework, we're working 7 through 12, no, 7 to 14. Those are all rate, time, distances. Then we're skipping down 21, 22. That's rate, time, distance. There's probably a little bit of variation, so here's 3 starters for you. 9, we've got train A compared to train B. And again, rather than spectate, I'd encourage you, try to fill in the table without me and then double check back in. But for 9, we've got train A, train B. Train A is 12 slower. Slow has to do with rates. How fast is rates? If A is slower, these both have to do with rates, but to make the train A slower, you could either subtract 12 from A or add 12 to B, but not both, just pick one. This is not the same as this idea. We're not having a vehicle being opposed and helped at the same time by a river or a wind. It's just one comparison to another. It's just going to be one basic add or subtracted. We've got same time, so T's. And then for the distances, we know train A is 230, and the same time that train B is 290. And then we could write the equation from here the same way. Since the times are the matching fact, again, I'd go to the time equation, again, time equation that we circled a minute ago, put distances over rates. So I would do 230 on top of its rate, because they're in the same line, on top of the other line's worth of stuff, 290 on top of R. And then cross multiply and go, but I'm going to bail out on 9 and make you finish that one. 12, we have a paddle boat going 2 if it were in still water, but it's not in still water. We're going to go downstream and we're going to go upstream. So this is our helping hurting problem based on this concept. We want the vehicle and stuff to go first, and then we're helped and hurt by the river itself when we go downstream versus upstream. So downstream we always add, upstream we always subtract. But we need the boat thing first. This time we know the boat. With the boat's capability is 2. So we're going to put the 2's first because the boat is first. Then the river we don't know. We don't know what the river's doing, so just put a variable on those. They say again, same time. So again, when times match, we would do the time equation, make our fractions by putting distances over rates. And we have going on here for number 12, 4 is the downstream, how far, 1 is the upstream, how far. And I'll just leave that to you to go distances over rates in each line, cross multiply, try to get that figured out. 13, Derek has money to rent a canoe for an hour and a half. So an hour and a half has something to do with time, but I'm not going to commit to that yet. He's paddling out on a lake, and then he's going to come back from wherever he's going to sit for a minute and take a rest once he's out on the lake there somewhere, probably. We are going out kind of slow. He's paddling out at a rate of 2 kilometers per hour. That little slash, read it as a per, kilometers per hour. And per means rate stuff. So he's going out, relaxed rate 2, just taking his time. Coming back, he's going to hustle. So that is 4 coming back. These times are not going to be the same, because if he's going to paddle out slow, it's going to take him a while. If he comes back fast, he's going to be back quickly. We have 1.5 total hours. That's not going to fit in the table. I'm just going to set that aside for a second. What we're trying to come up with are the distances. The distances have to be the same this time. Okay, so the distances out back, it's got to be the same distance. So with same distances, I'm going to go look, stroll to the left, use this distance equation, and we are not going to get fractions this time. I was telling you, expect mostly fractions, and they mostly are. But if it's the distance that's the same, and we use the distance equation, we're going to do the rate times the time this time. So we're going to go this box times this box, equaling this box times that box. But first we have to figure out the boxes. Okay? The boxes are both variable based because we don't know what the time is. So here's an idea we've gone through before. If I would tell you that I have like 10 cookies and I'm going to give 4 to one student, you could figure out that I'm going to give to another student 6, because 10 minus 4 is 6. If I told you I had 10 cookies and I was going to give 2 here, you could figure out by doing 10 minus 2, somebody's getting 8. If I had 10 cookies and I gave somebody X, following the trend we were just building momentum off of, 10 minus 4 makes 6, 10 minus 2 makes 8, 10 minus X makes 10 minus X. It's the best you could do. On this story, I don't have 10 cookies, I have 1.5 hours. So we have 1.5 hours. T of it could be devoted to going out. 1.5 minus T is what's devoted to coming back. If I have T hours to give, or excuse me, 1.5 total hours to give, and I give T of it to one thing, I have 1.5 minus T to give to the other thing. Again, equation for this now, since the distances were a match, we go to the distance world, rates times times. So I need to take the 2 times the t for the rate times. So again, what we had going on here, since the distances were the same, we had to base ourselves off the distance equation. So we're doing rates times time. So rate times time is this, rate times time is that, and our job's now going to be do some distributing, do some solving. We're going to get eventually a time figured out, and then just once you get the time figured out, make sure you read and see what they're asking for. So if they're asking you, if you get the time figured out, and they ask you for the time it takes to get out there, you're good. But if they ask you for the time it took to get back, you're going to have to do 1.5 minus this. Or if they ask you for the distance out, you'd have to take 2 times the time we're about to get would give you the distance out there. If they want the distance back, it's just the same. But if they asked for the distance total, you'd have to do this number plus itself to get a total distance he rode the boat. So just be careful on this one, and really any word problem. Make sure you always read the last sentence carefully to see what exactly are they asking you. But there's 13, and you should be set up to do everything else. So good luck. We'll see you soon.